2.5 Admins, episode 113. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. Let's do some feedback then. Manu says, regarding the episode where you covered backups, Gary said Borg or Restic need a file system mounted to do backups. He gave SSH, FS, and WireGuard as examples to mount a remote file system across the internet. This is wrong for both. Restic sends backup data directly to a remote backend, which is most commonly some HTTP-based object storage, like Amazon S3 or Backblaze B2. No remote system or VPN like WireGuard is involved. For Borg, it sends backup data to another Borg instance over SSH and message pack. Again, no remote file system or VPN involved. Jim rightly said that not everyone is using ZFS and should use rsnapshot in such a case. Personally, I don't think setting up rsync and SSH is any harder than Borg or Restic, probably similar. The one advantage of an rsnapshot style backup is that it can be read without any additional steps or tools. The main disadvantage is that every snapshot recreates the whole folder structure. After a while, one ends up with millions of files. If there are many folders or modified files, this can even exhaust available inodes. It's also near impossible to move elsewhere because all those hard links need to be resolved during copying. Other drawbacks of this backup style are the lack of deduplication and encryption. Lack of deduplication means that renaming a folder will retransfer all the data and double storage use for the renamed folder. Encryption is obviously important when hosting backups with a relative or cloud provider. Given the similar effort for the setup and major drawbacks, I wouldn't recommend the rsnapshot backup technique in 2022.
Yeah, I think those are pretty much all valid points, although it really points out why ZFS replication is such a great tool for backup, because it deals with the rename case without having to copy anything but the metadata about the rename, and you get all those snapshots without actually creating all the files. What might be really interesting in the future is ZFS is getting in this new feature called BRT, the block reference table, which allows you to basically clone part of a file. And if rsync and rsnapshot could learn to do that, rather than a hard link, we could have a copy of all the blocks of the file that are the same, but have the local differences where it only takes the same amount of space as a ZFS snapshot would. Although if you're doing it on top of ZFS, why are you using rsnapshot backup anyway?
I feel like the nitpicking about remote file system and VPN is exactly that. It's nitpicking. It is technically correct, but I'm not sure that it really matters within the scope of the question. Saying that, well, you don't need a file system because you've got HTTP-based object storage. Well, that it serves the same purpose. It sits in the same place. It's still a thing that you have to have and you're interacting with in much the same way. Similarly, I don't think that there's a difference that matters between a VPN and moving data across an SSH tunnel. Either way, you're talking about a way to securely move data encrypted point to point between 2 points. Now, the hard link issue, that one's a lot more on the money. As a matter of fact, moving back to Alan, immediately pivoting it back to ZFS, that's actually exactly how I learned the value of ZFS replication to begin with. I had been using rsnapshot-like backup mechanisms for customers of mine for a very long time. I had written my own tool that functioned a lot like rsnapshot. Stupidly, I never open sourced it because this was much earlier in my career, and that's why nobody but me even knows this thing exists, while rsnapshot is a well-known tool to millions of people. But either way, we both relied on the concept of hard link trees. So for a hard link tree, you rsync in all the data, and then you make a folder. And for example, that folder might be named after the current date stamp. And now you grovel through your rsynced data, and you make a hard link of every file from the original location into the new folder that you just created. Now, the obvious drawback is you have to stat every single file. You got to touch every single file to do this and create a new inode for it. As Manu mentioned, you can completely exhaust your inodes, but what actually happened to me is I had a customer that had, years of such backups, and yes, it was millions of files, and it's not just a case of it would take forever to move it from A to B. It was literally impossible because to rsync this stuff from, the existing backup server to the upgraded backup server I had built for them required more RAM than it was physically possible to stuff into a machine at that point in time. So I fought this for like a week or two before finally I started reading up because both of the machines in question were actually ZFS underneath. And I started looking at ZFS replication, which I had up until that point ignored because I had rsync, and rsync was like the best thing ever. So what do I want with that ZFS replication? Well, I read up on it and I learned how to do it, and I tried ZFS replication instead. And because ZFS replication is block level, it doesn't have to go through and stat those millions of inodes. It just barfs the whole stream of data from one machine to the next. And what not only would have taken months if it was possible, and in fact was impossible because I couldn't cram enough RAM in both machines to hold the entire list of all the files that need to be moved, ZFS replication didn't care. Just worked. The data took about 18 hours, I think, to replicate from machine A to machine B. And this was long before I had, written a tool like Syncoid. Again, it was my very first effort at ZFS replication. I didn't even know about PV yet. I'm not sure if PV existed. So the real problem was that once I had begun my first real-world use of ZFS send piped over SSH to ZFS receive on another machine, I just sat there staring at it for 18 hours until it finally said, "Okay, boss, I'm done." And that sucked.
A couple of years after that, they added the -v flag where it'll at least print out its progress once a second so you have something and know that it's still moving. But when it's just the cursor sitting there blinking at you, you're like, I don't know if you're doing anything or not. I can run ZFS list on the other side and see this free space keep going down, so something's happening, but...
That is exactly what I ended up doing, which was nice because you can see at least something is happening, but you still don't really have a good idea of when it'll finish. So yeah, I was literally just doing watch N1 ZFS list on the target machine, and as long as the number was going up, okay, it's doing stuff, looks good so far.
Yeah, the other one was, when he mentioned this, I forgot that you could run out of inodes because that's not a thing in ZFS because they're dynamically allocated, and so you run out of space, not inodes. But I've run out of inodes in other file systems, and I forgot that that's actually still a thing for everybody else.
Yeah, if the machines in question in my story had been using ext4, they wouldn't have been able to accumulate all that data to begin with because there would not have been enough inodes. Even if they had been formatted newsgroup style, which gives the ext4 file system a much higher percentage of inodes in relation to the total free space, it still wouldn't have been enough to hold all that nonsense.
Yeah, I know UFS, you can tune the number of inodes after, so you can actually add more later if you need to. I don't know if newer ext can do that or not.
I don't think so, because when you format with ext4, you have to pre-allocate all your inodes.
Right.
So what about Manu's overarching point here that if ZFS is not available to you for whatever reason, the old school rsync method is inferior to a more modern method of backups?
So the rsync snapshot thing has drawbacks because of the hard links. It mostly comes down to how many snapshots you're keeping. If you're keeping a reasonable number, like a small number, it's probably okay. But if your intent is to keep like every snapshot ever, then possibly something that uses object storage might be more interesting. Because you can actually run into problems like Manu mentioned with the running out of inodes or just huge things, or the fact that you rename one file folder and now you're actually duplicating it. And the fact that unless you're using something else in addition, you're not getting any encryption. All of those are real concerns. They might not apply to your use case. It depends on the scale, but they are legitimate criticisms.
I think that the key there, Alan just hit on it, is, depending on the use case. I think that most of Manu's criticisms, they make sense. There are absolutely advantages to using something like Borg or Restic. I do think there are also real advantages to the simplicity and, the file system native way that rsnapshot works. The fact that you can just work with that data directly is a big plus. It means that you don't have to worry about some of the issues you can have with corruption in an object-based system that are not necessarily going to apply with the file system. It can be more difficult to extract the data depending on exactly which object-based store you're backing up to, because it's not just files. You got to get it back out of there, which was never something I appreciated about traditional style backups. With that said, the advantages that he mentioned are genuinely advantages, and if those are things that you really need, yeah, absolutely, you should use Borg or Restic. If those are not things that are a big deal to you, then, well, we're back to, I do disagree with his statement that it's not any harder setting up Borg or Restic than rsnapshot. I'm not going to say he's wrong in some kind of universal absolute sense. I will say I absolutely categorically disagree. I've set both up, and I find rsnapshot a lot easier to get going with.
And there is something attractive to me about just being able to know that you could just pull a hard drive out, stick it in another machine, mount it, and just have all those files there.
Exactly. I never enjoyed the process of restoring from tape backups where first you've got to mount the tape and catalog the tape. And, that might take a couple of hours. And, then you can actually begin extracting data from the tape onto the drive in a way that you can actually use it. You don't really know if you've got anything until you're done with like all this nonsense versus being able to just CD path to backup ls-l. That's for me.
Yeah, and I mean, you could even argue, it's much less so with ZFS, but having to, certainly on Ubuntu, install some stuff and then import a pool. It's not massively different from mounting an ext4 file system, but just the simplicity of just a mount and knowing that even if you mount it read-only, that is why, as part of a backup solution to me, just having at least one of those in addition to your ZFS or whatever it is that you're using, just having one of your backups be an rsync to a traditional old school file system, I feel like I'm going to cling on to that almost forever.
If you can. There may come a day that you're working with, 3 terabyte VM images and you discover that, that's not going to work for that. I need something different.
True.
Yeah. To that point, even because there's always some risk, we talked about always having one backup that's different or whatever. Even if that's literally just rsync to another ZFS, just the fact that it's not replication, it's all the files are recreated, can be worth it. But yeah, having a backup that's a different file system helps ensure that if something is wrong with the file system, that you have a backup that's not going to be affected by the same bug.
Yeah, technological diversity.
Yep.
That same potential issue I tend to approach from a different angle. I have 2 backup targets, and one of them is a rapid backup target. It's typically going to be on-site, and it's going to get hourly replication. And then I will have a slower backup target that's typically going to be off-site, and it's going to get a daily or even less frequently replication. And what that does is it gives me a little bit of time to detect it. If there ends up being some file system bug that bites me, I've got a chance to figure that out while it's affecting, the hourly on-site, but before it's had a chance to nail the off-site. So that also buys you a little bit extra because, again, just the nature of the data I'm working with, I would love to also have, like an rsync style backup, but it's just not practical. Nothing else replaces ZFS replication for what I do.
Same thing. I'd love to have all of my data in the cloud if it wasn't stupendously expensive and wouldn't take months to upload and years to download or whatever. But instead, there's 2 gigabytes for a certain folder of, my personal taxes and so on that gets backed up to the cloud, and the rest is just on-site and off-site ZFS.
Well, it's like I have a few hundred megabytes of the key assets for my shows, artwork, music, that sort of thing, that's in the cloud. And I know that if everything just disappeared, I could get that one last-ditch backup and I could make my shows again. It would be harder. I wouldn't have my templates and my historical edits and all the rest of it, but just having that absolute bare minimum in that one extra place can be very handy. I hope to never use it, but, that's the point of offsite backups, I guess.
I guess the thing for me is everybody all just makes the assumption that the cloud will always be there and the cloud will always be fine. And that's not really the case. I have yet to lose any of my own data on ZFS systems at all, period. Whereas Microsoft has lost data of mine in their cloud, Google has lost data of mine in their cloud, and Amazon has lost data of mine in their cloud. Does it happen a lot less frequently than typical users or even typical admins, will screw up and lose data? Yeah, I think that's probably fair to say. But is it, it's in the cloud, so I know it's good? No, that's a mistake. You still need to be responsible for your backups.
Well, I treat the cloud like just another storage device. Just assume that it's going to die at some point.
Yeah, that's the way to treat it. That is a correct assessment.
Okay, this episode is sponsored by Kolide. The challenge with endpoint security has always been that it's difficult to scale. And when remote work took over, the challenge got exponentially harder. You need visibility into your fleet of devices in order to meet security goals and reduce service desk tickets. But how do you get that visibility when different parts of your company run on Mac, Windows, and Linux? You get Kolide. Kolide is an endpoint security solution that gives IT teams a single dashboard for all devices regardless of their operating system. Kolide gives you real-time access to your fleet's data and can do things that traditional MDMs can't. And instead of installing intrusive agents or locking down devices, Kolide takes a user-focused approach that communicates security recommendations to your employees directly on Slack. You can answer every question you have about your fleet without intruding on your workforce. Visit kolide.com/25A to find out how. If you follow that link, they'll hook you up with a goodie bag just for activating a free trial. That's kolide.com/25A. Steganography alert, backdoor spyware stashed in Microsoft logo, says the register. This is combining two files together, hiding malware within an image. I remember 15 years ago combining zip files and JPEGs, and you get like a 5 or 6 megabyte JPEG that was tiny when you looked at it, and it would have, an MP3 in a zip file or something. But obviously, that's being used for malware.
And that's exactly what we're talking about. The thing is just that if you remember coming up with a tiny 5 or 6 megabyte JPEG file, you were trying to cram too much data into your sneaky steganographic JPEG. Normally, you hide small amounts of data in a relatively large JPEG, and it becomes very difficult to figure out that there actually is data embedded in there. If you know this steganographic algorithm being used to hide data in the image, then you can run the image with the data back through the algorithm and separate the data out. But if you don't already know either that this is an image with a payload or what algorithm was used to put the data into the image, well, you're going to be out of luck because visually you can't really detect it. There are some statistical analysis tools that can give you a high degree of probability that data has been crammed into a JPEG because it doesn't quite look right from the machine level, but you're still just kind of guessing and you won't necessarily know what that data is.
But the key point is, if you hide it in a JPEG, you can then put that JPEG somewhere like GitHub, which is a trusted site. If some software downloads from GitHub, it's not going to cause any red flags.
Yeah, I think that's the big thing here is that, so they're hiding the malware in the image, but it's not like they're sending the image in just by looking at the image, you're going to get the malware. Or you double clicking on the image, it's going to run the malware. It's more using it as a way to hide the malware so when they host it online, they can host it on Facebook or GitHub or somewhere so that when the network security team at the place, like the government in this case apparently was the target, they're not going to see connections off to weird bulletproof hosting servers in China or Russia or something like that. They're going to see connections that seem innocuous and are going to trusted sources. Like you could host something on Google Photos or something with a URL that looks like it's just something that you would normally see a browser going to, but really it was downloading the malware and being able to execute it.
And for that matter, it truly is a viable image. You know, we're not just talking about saving a malware executable malware.jpg and like you run malware.jpg. No, like you can open this thing up in an image viewer and see the actual image. And in this particular case, the attackers were embedding a very small footprint payload into a JPEG of the old Windows. I'm not sure if it was the Windows Vista or Windows 7 logo.
I think that was the 7.
The limit to this technique is you can only encode a relatively small amount of data before it becomes obvious that something is up if you actually care to look at it. JPEGs aren't necessarily even the best tool for that. They're handy because it's easier to put a JPEG someplace like GitHub and have it not look out of the ordinary if you go to get it, and also to be relatively certain that another image algorithm won't compress it or, reduce it in size or otherwise monkey with it. Because if you run this JPEG through Image Magick or whatever, you will absolutely destroy your steganographically encoded data. It will not be valid anymore. So you need a host that won't alter the file. But if you were really feeling tricky about it and you had more data that you needed to encode than you could safely cram into a JPEG, there's not necessarily anything stopping you from encoding a much larger data stream, for example, into an MPEG. Put that thing up on YouTube. Now, it gets a lot more complicated there because YouTube has its own certain algorithms and codecs and resolutions that it's willing to accept, and it does tend to monkey with things. A video that you upload is not necessarily going to come back exactly the way that you put it up. But if you're careful and you upload an MP4 that's encoded exactly properly at exactly the resolution you want, when you go to view that video file again, as long as you view it at the proper resolution that you uploaded to begin with, and YouTube hasn't re-encoded it as part of that process, you could potentially be looking at getting many megabytes, maybe even hundreds of megabytes of data back out of that thing with nobody the wiser.
That'd be very, very difficult, though.
Not necessarily.
Not that difficult.
If you can encode it in the video file and in a way where Google's not going to transcode it, or it's going to transcode it into a bunch of different ones, but as long as you're going to be able to access the untranscoded version, then yeah. And the best part is you're getting all the hosting for free. Because, if you were doing a couple hundred megabytes or something times thousands of machines are going to download this, that would cost you a lot of money at a CDN, and you're getting it for free by hiding it in a YouTube video that isn't necessarily going to get a lot of views. But because if you look at it, there is an actual video there, it's not going to get taken down right away as being detected as malware.
Yeah, and YouTube's probably one of the best CDNs in the world.
And obviously the correct video for this attack is Rick Astley's Never Gonna Give You Up.
Yeah. Well, that might actually get taken down for copyright.
Yeah, exactly, yeah.
You'd have to do like an animated version of it with bad music or something.
You could do the Never Gonna Hit That Note version.
There you go.
Which, audience, this has nothing to do with system administration, but if you have never participated in a viewing of Rick Astley Never Gonna Hit That Note, I encourage you to Google it. It's wonderful.
In closing, they note that the Wacheti malware has demonstrated the ability to continually refine and refresh its tool sets in order to compromise targets of interest. Exploitation of vulnerabilities on public-facing servers provided it with a route into the organization, and then they were using custom tools paired with Adept's use of living off the land tactics allowed it to maintain a long-term persistent presence in the target government.
This is also, by the way, one of the better arguments for using traditional antivirus, which I'm normally not a real big fan of. Traditional antivirus is very expensive to run, has a serious impact on your machine in terms of the latency that you experience while you're trying to go about your day and do your work, because there's so much else going on with every data stream that crosses the machine. However, when you look at a tactic like this, traditional AV running directly on the endpoint is basically your only shot at catching it, because you're not going to detect that data while it's stenographically embedded into a JPEG. But if your particular malware that you have embedded is something that is in a traditional AV database or would trip the heuristics, then you've still got a shot at figuring it out. Once that data stream emerges from the JPEG, it's going to go through your AV library, and if it's detectable, that's when you're going to nail it.
Okay, this episode is sponsored by Linode. Go to linode.com/25A, support the show, and get $100 free credit. From their award-winning support, offered 24/7, 365 to every level of user, to ease of use and setup, it's clear why developers have been trusting Linode for projects both big and small since 2003. Deploy your entire application stack with Linode's one-click app marketplace, or build it all from scratch and manage everything yourself with supported centralized tools like Terraform. And check out their managed MySQL, Postgres, and MongoDB databases that allow you to quickly deploy a new database and defer management tasks like configuration, managing high availability, disaster recovery, backups, and data replication. Simple and fast to deploy with secure access, their flexible plans include daily backups. So go to linode.com/25A, create a free account, and you get $100 in credit and support the show. That's linode.com/25A. Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed. And if you want to send in your questions for Jim and Alan or your feedback, you can email show@2.5admins.com. And do send in your questions. And as I always say, the shorter the better. Leandros says, I'm trying to decide if enterprise SSDs and their power loss protection are worth the sizable increase in cost over consumer SSDs for a home lab setup. Does power loss protection have any influence on an SSD's use of its DRAM cache? Meaning, and forgive my ignorance here, do any conservative file systems instruct a drive's firmware to skip the DRAM cache to write directly to the disk, thereby avoiding instances of the drive reporting a write but losing the write in cache with a sudden power failure? And my SSDs with PLP tell the file system to F off and continue to use its DRAM cache, resulting in a speedier drive. Am I nuts?
So no, the power loss prevention is just backing that DRAM, keeping it working long enough so that it can write out the data and not lose it. So the file systems don't really control that. What they can do is they issue a command called a flush, where they say, I've written a bunch of data, and now I'm saying, don't return from this command until all that data is all the way out of the DRAM and safe on disk and will survive a power loss.
Sort of like the equivalent of an and sync.
Yeah, so basically that's kind of what a sync does, is actually issue that flush to the hard drive and wait until it's finished. Whereas most writes will return right away saying, sure, I've buffered that into my DRAM, and if I have power loss protection, that's good enough, because if the system does crash, I'm going to keep the DRAM alive long enough to finish the writing. But, for example, ZFS at the end of every transaction group issues a flush and doesn't consider that transaction group complete until the drive acknowledges that flush. Now, some SAS HBAs that do like hardware RAID will lie about that and acknowledge the flush immediately if they have a battery backup or something to keep their cache alive long enough to finish the write, because that will make the storage seem a lot faster, because you've asked for a flush and I've lied and said I flushed it even though I didn't, because I have enough battery backup to keep it going long enough that you won't lose the data. And some cheaper SSDs might do something like that as well, but you really hope that they won't. There was quite a few stories about that when somebody thought Apple's new NVMe drives were doing that, but that was actually a difference between the type of flush they were asking for.
Now, to be fair, this is really only a problem when HBAs and RAID controllers and drives that don't have functional power loss protection do that lie and don't honor the write barrier. Because what the write barrier really says is you have to commit this to non-volatile storage safely. Going back to ZFS, as Alan said again, like that's what the ZFS intent log is for. You can complete a sync write to the ZFS intent log, which is a simple streaming ring buffer, a lot quicker than you can commit it to main storage out in a TXG. And also you can do it immediately rather than needing to aggregate it first to make sure you don't overly fragment your data. So when ZFS has committed that data to the ZFS intent log, even if it hasn't gone out as a transaction group yet, it can return from that sync call and say, yes, I've safely stored that data. Now, if you've got an SSD with power loss protection, it's basically the same situation. Once that SSD has accepted that data into DRAM, it can say and not be lying, this is now in non-volatile storage. And the power loss protection is the reason it can say that and not lie. Now, the net effect here, it's basically nil unless you have a sync write heavy workload. If you're doing a lot of sync writes, then having SSDs with power loss protection means the sync writes go just as fast as the asynchronous normal writes do. You no longer have a much different performance profile because, again, as soon as they're into the DRAM cache on the drive is allowed to say, yes, it's safe. Because what will happen if you have a crash or a power failure or what have you, and again, specifically because it's on drive, this is safer than when you've got like a battery-backed RAID controller. A lot of things can still go wrong in between the battery backup or the supercap on a RAID controller and the actual disks to keep that data from being safely committed. But when you're talking about DRAM cache on board a drive in firmware, there's really not anything to prevent that drive from being able to safely flush that data out as it promised to, because the data is safe with power loss protection in DRAM, and once full power is available again, it will complete that write. So to more directly answer Leandros' question, which was, might SSDs with power loss protection tell the file system to F off and continue to use the DRAM cache, resulting in a speedier drive? Am I nuts? No, you're not nuts. That is actually how that works.
Yeah, and for the previous part, it's not just conservative file systems that can instruct the drive's firmware to do that. It's like normal writes, like if you're copying a file, you're always doing that. You're just saying, I'm giving you the data, you say it's done, I believe you. But oftentimes you'll do a sync at the end of that, a flush at the end of that, to say, now that the whole file's there, I don't want to exit CP until that's actually finished. So every file system knows how to tell the drive, hey, I want a write barrier here. And that can be important. And so it doesn't need to be a conservative file system, but most file systems will do most of the workload asynchronously and only do the synchronous version with the write barriers if the application asks for it. And that's kind of what Jim's point was. The only time this really matters is an application like a database or something where you're doing a lot of these writes where the application wants to wait until that write is definitely going to survive before it goes on to the next step. And that's where having the power loss protection means that can happen a lot more quickly, because as long as it made it to the RAM on the drive, even if it hasn't made it to the storage yet, it's okay to acknowledge it and let the database go on and do the next transaction and the next transaction.
And without some kind of acceleration like this, a sync write workload is incredibly slower than a normal asynchronous workload. So if you do have a lot of sync writes, PLP can make an enormous difference. In the ZFS world specifically, there's not really a whole lot of point to having a log VDEV if you're using power loss protected SSDs in your main storage. It's just not a whole lot of reason to do it because you've already got you've got even more acceleration available from the power loss protection.
But your slog should be an SSD with power loss protection.
Ideally, yes. That's not a requirement, but basically having power loss protection on your slog can prevent you from having to basically time travel back 3 or 4 seconds in terms of, data. Like you're not going to end up with corruption in your data because you didn't have power loss protection on a slog, but you can lose dirty data otherwise.
Right, but more it was if you're picking a device to have a slog, you're having a slog because you're doing enough sync writes that the performance of those matters, and a drive with power loss protection will be probably magnitudes of faster than a drive without it, because the drive without it will have to wait for the flash to actually finish the work rather than just the DRAM.
Right.
And to your other point, like if you have literally a single spinning hard drive and you're doing a full sync write workload, you'll be lucky to get more than 1 or 2 megabytes a second of write speed to that drive.
Mm-hmm.
Like 4K random writes to a hard drive. Even if your hard drive normally copying a file can do 200 plus megabytes a second, it's going to struggle to get more than 2 megabytes a second of random writes because it can't move the head to that many different locations that quickly.
You may not even get 1 megabyte a second.
Exactly.
Now, before we move on to the second question from Leandros, I do want to go ahead. For those of you who aren't sure, do I or don't I have a sync heavy workload? Your common culprits for having a lot of sync writes are going to be databases, virtual machines, and finally, if you're doing NFS exports for your NAS, NFS traditionally uses sync writes for all writes.
It depends on the client. VMware is very bad for definitely doing 100% sync writes. Other NFS clients, it can depend on the client, but yes.
It can depend, but my point is those are your common culprits.
Yes.
All right, so moving on, Leandros also asks, in a home lab setting, would you personally risk using non-PLP consumer SSDs in a mirrored pool that has regular nightly backups and an uninterruptible power supply? And a very simple answer, yes, I absolutely would. And in fact, I do.
Even myself, I think only one of my machines has the higher end PLP SSDs that's actually a server. Like my home NAS definitely is just cheap consumer SSDs. Because yeah, you should depend on your backups and so on. And in particular, my home NAS, if I lose the last 2 seconds of what I wrote for it before the power went out.
You might have to download a couple of episodes again.
Yeah, they probably were in the process of being downloaded, so I won't even notice that I'd have to download more.
Right, well, we better get out of here then. Remember, show@2.5admins.com is the email address to send in your questions or your feedback. You can find me on Twitter @Joe Rissington.
I'm at JRSSNet.
And I'm at Alan Jude.
We'll see you next week.